Okay. So any doubt or query from anyone before we begin? So it's okay, fine. Uh, let's today start with the us data frames. Let me second so I can share my screen. Okay, just a second. Let me just share the tab. That will be more better. Uh, this is all what we have covered yesterday. We have done with the NumPy. We have seen the 2D array in the NumPy. Then we have covered the basic method and functions in NumPy. Okay. Now let's start with the okay, first of all, one thing what is left there is the copy command. Apart from the copy command, uh, okay, yeah, copy command. Apart from the copy command, we have some more few important functions to generate the values in a given range. Okay, so it's like if you have to generate value between the 0 and 1, so how you can generate the value 0 and 1? If I have to generate the uh, 10 values between the 0 and 1, so how I can generate? Or if I have to generate the values between 0 and 1 at the given so how I can generate that thing? But arrange, and other is which is used to generate the values at the linear spaced or the equally spaced number between the given range. So before we start, let's come to the copy command, copy method. Why copy method is an important one? So for that, I will be taking a sample array. So let's take an sample 3D array. Let's me little bit zoom in. Okay, that's fine. Connect to the cloud runtime. That will take a while. Okay. Just a minute. Why it's not connecting? Okay, it's fine. It's connected now. So let's build an array, sample array. Let me call this an array A equals to np dot array. It has 1, 2, 3. First row, we have 4, 5, 6, 4, 5, 6. Okay, 7, 8, 9. So it is an array of 3 by 3. Now, okay, let's just a little bit. That's fine. No issues. I can print that array, print array. Okay, array. And B. Okay, just a second. So now, if I need some part of this array, for an example, if I need the this 2 3 5 6, so I can use the slicing for trimming out this 2 3 5 6, the first and second row, and second last and last column. So there are multiple ways of doing the same thing, multiple ways of doing the same indexing, same slicing. So let me make an array b, array b, which is equals to a slice of a array A. So first will be the row, then it will be the column. So I want the 0 row and 1 row. So I can say 0 to 2. That will give me the 0 and 1 row. Now next I want the this central, from the central column to the last column. So I can say from 1 to last. Let me show you once before trimming. Sorry, before slicing the thing. So this is what we want, 2 3 5 6. Okay, so let's just say b equals uh to this part, this slice of an array. Now to the b, here we have the b slice of array a. Now array, let's call this array b, that will be more better. This is array b, this is array a, and selection for the next line, and array. Of the array A. Next, okay, it's fine. If I make any changes in array B, if I have to change the value, for an example, I have to change this 3 value. If I make a change in this 3 value, and let's make this 3 as the -1 or whatever, something, whatever you want, you can just assign, just I want a random integer value. I want to just demonstrate if I make any changes in the b, then what will happen. That is what I want to demonstrate. That is my main target. So I can say array b in any of the array b value. Now this 3 is at the 0th row and first column. So I can say here 0th row, first column, which is the b. It's 3. Its value is 3. Now let's make it something like -999 or whatever. Just run the code. Now after making the change, let's see what is the value, whether that change has been done in the array b or not. So let us print the array again, array b again after that change. Oh, oops, just a second. Let me do this in next shell. Here it will be more better. Okay, done. So after this, you can see here the value of array b has been changed. Now it is in place of 3. Now it is minus triple nine. Now let us again print the array A also. So let me print the array A also here. So I can say here print array A also. I can just slash n. Here also I can add this next line character for the better view. Array. So the important thing is that I am making only change in array B, but that change is also done in array A also. The value of the array A also has been changed. Why this happened? This happened because when you do the slicing, it doesn't create a new array in the memory. It just reference the value, reference to the address of these value in the memory. That is what is done here. It is not creating a new array or the new part slice of it in a memory. It is just referencing those value pointers, those value memory addresses pointer. So whatever will be at that memory address pointer, that is because both. So when we are making any change in the array B, when we are making any change in the array B, that means indirectly we are making the that change in array A only, because array B is only referencing the portion of the array A. So any change that will done in the array B, that will be also iterated to array A, because B is the only copy of array B, which will be containing the same or pointing the same addresses of array A. So how we can prevent this thing? How we can force or ask Python or the NumPy to create a new array when we are doing something like this? So to create a new array in the memory, when you are by using this slicing, you have to use the copy operator. You have to say array C, which is the copy of, now it will be a copy of array A. So I can say array A, same thing. I am using the same portion of the array A, what I have used for the array B. Now dot copy, dot copy. This is also the slice of array, but now in this case, it will create a new copy. Create a new copy in basically RAM. Okay, I can say RAM or memory, whatever you want. You can say that thing. Now let us just also print the array C. First here, let us say the array C, and that will be the array C here. Okay. Now, if I run this thing, so for by looking at, you cannot differentiate between the array B and array C, but actually array B is only a reference to the array A value, while array C is the totally new copy of the slice of array A. How we can say this? If I make any change in array B, you can see here there will be no change in array C, because that is the totally new array in the memory. You can see here clearly. So any change in the array A or array B, that will be not forwarded to array C, because it's a totally new copy. So that is what copy command do. It's create a new copy in the memory. Now secondly, what happened if when we make any change, so that is the same thing, vice versa also is true. If we make any change in array C, that will not happen in array B or array A. So that change will be not in array b or array a. So let me just take another, let's say 0 comma 0. So very first value, so let us assign very first value as -111, something like this. So now you can see here any change in array c will not be in array a or array b. So let's take the first the array c. Okay, so here let's take here the array b, let's take here the array b. So any change, you can clearly see here, any change in NAC that will be not iterated to array A or array B. So this is what we have the copy command. So this was an important. Uh, Another thing, we have the arrange and the linspace. Okay, arrange is very similar to a range function in the Python, but the difference is that range return the range object, arrange return the numpy array. So that is the one of the difference. Another thing is that range only works on the uh, integer value, while arrange can work on either the integer value or the float value. It can work any of those. So let's see, we have the range. Okay, so range only work with integers, so that is the first difference, only works with integers. Okay, secondly, uh, it returns range object. Okay, it will be returning the range object. Now if I just store this into a some result r, and let's take it from something like, okay, let's take it to 10, that is from 0 to 10 with the gap of 111. If I print the type of the r, you can clearly see that it will be an range object. Returned, so I can say here the type of r, so that will be an range object. Now when we talk about np.arange, in that case it can also work with the floating value. Okay, so if you try to operate the range on the floating numbers, if I say equals to range of 10.0, that will throw an error. Okay, type error, floating object cannot be interpreted as an integer, because range work on the in this on the integers. So that is why we have got that error. Okay, but if you talk about the arrange, so let's take this result, np dot range. Okay, a range means array range, because it returned as an array na, as a result, so that is a array range. Now let's take 0.10. So in this case it will generate value from 0 to 10 with the gap of 111. Works with floats also. Okay, return numpy dot nd array. Okay, and dimension array. So we can also check the type of the object return. In this case it will be a numpy array. We can also print the array result r. That's good. So you can see here it's written an numpy array, and also work with the floating values. If you have any doubt or query, you can ask. You can try out side by side. Now there are a few special matrices generation method also there in the NumPy. We have the method to generate the matrices of only one ones. Okay. Uh, have the method to generate the matrices only of 0 0 0 0, and then we have also the method to generate the or the create the empty array. Okay, it's just like the allotting a space in the ram. So so if we have to generate the matrices of only 1 1 1, in that case we can say once the matrices of 1 np dot once. Okay, then you pass the shape, whatever shape you want. For an example, I want the matrices of 3 rows 4 columns. Then by default it will be the floating value. By default it will be a float type. If you want some d type, you can pass that d type. If I want strictly to an unsigned integer of 8 bits, so I can say unsigned 8 bit. Okay, so that will be the unsigned 8 bit. Okay, int 8 bit. Next thing, we can also generate similarly like the matrices of 0 0 0. Let me just add the print method here. Okay, then we can have the here of zeros, zeros, zeros. Okay, and okay, of the zeros, Sorry. Okay. Now I think I am audible. Okay, thank you. So what I was telling you that as the numpy is written in C and C++, so what will happen, uh, we when in the case of the C++ or C, when you declare an array, so when you declare an array, in that case it just allot a space in the RAM depending upon the data type. So how much space to declare, that depends upon the data type, either it is a float type or a long type or the int type. Based on that, it just allot the space. So without initializing the value of that array, if you print the value of that array, it will show you the garbage value. So that garbage value is actually the uh, value at that RAM addresses. That might be due to the some previously loaded data, that type of a thing. Same happen when we initialize np.empty. We are just creating a array. We are, just like we initialize an array in the C++, similarly we are here just creating an array. So it is not generating a random value. Remember, this is not for generating a random value. For random value, we have the np.random module in the Python, random sub packages in the Python. From that we can generate the random values either using a uniform distribution or the standard normal distribution. Here it is just pointing the space, it is just allotting the space, and values are the garbage value at that pointed space in the RAM. So this is not the random value, but it's wherever it's giving me a space, the value at that space. We have this empty array. Okay, so we have an empty. It's just like if you want to replicate the C array declaration thing, ones and zeros. Why we have the ones, only ones and zeros? Because uh, zero has the property, if you add a zero to a number, it return that number. So a plus zero is a only, so that's why we have the np dot zeros. Then why np dot ones? Because it is a multiplicated property. When you multiply a by 1, that will return only the a. So due to the additional and the multiplicative property, we have only the array of ones and zeros. Then later on you can assign, or you can initially you can create an empty array and then you can assign all those values. Whatever way, yeah, it's up to your use, how you use, how you are using the thing. So these are the one important, some of the important method in the numpy array. Okay, now if you have any doubt or query, you can ask. Otherwise we will be moving forward to the pandas. Okay, just let me share you the, you can go through the things. I am sharing in the meeting chat all the code. You can either you can copy paste or you can type yourself. Now we will be starting with the pandas. Look, basic objective, basically main objective is of pandas is to make visualization easy for the human. Because most of the thing, 90% of the thing what we can do with the pandas, that we can similarly do with the numpy also. But visualizing the numpy array is quite difficult. When we are doing the things like the data analysis, we are cleaning the columns and the rows, it's very important to analyze what type of data there is in column. For an example, sometimes what had happened, the column like which might containing the cost price or the price or the age like thing, and and if there isn't some uh, null value or some garbage value in that column, might be to that garbage value comes something like the question mark. So to analyze that thing, so what type of value the column contain and what is their real data type, because in the case of the pandas each column has the different data type. So pandas, in the pandas similarly we have the numerical type data. In the numerical type data we have this the float type, we have this the int type, same way int 8 and 64 and 32 whatever. Same for the float also, float 16, float 32, 128 and so on. And we also, other than the numerical type, we have the date time type. In numpy also we have that uh, the date time type. Then uh, in recently in the pandas, in pandas 3 which has been released few month ago, that now we have the string type. Previously we don't have the string type in the pandas. uh, the column which contains the string type, pandas allot that column as the object type. Object type means it contains the multiple values. There are the multiple values in the data. That is what it denote, the object type. Look, according to me, string type doesn't play any important role while establishing the machine learning relationships. Because when we are building a machine learning, we have to check for the relationship. And if you have the all the unique strings in the column, they have no use until if you are not going from the natural language processing. Like for an example, if you have the customer feedback and you are going for the natural language processing, in that case only the all unique strings are important. But when you have like invoice number, so from the invoice number we cannot generate any relationship. For generating a relationship, in the categorical, the data must be of categorical type, like gender type, job type. Okay. uh, it's raining or not, that type, boolean type. Okay, so when we have that type of data, categorical data, so string type in the case of the machine learning, only categorical data is important. And in pandas we have the categorical type. Previously, before 3 also we have the categorical type, and 3 also we have the categorical type. But string type, according to me, that's not important, because all the invoices are unique, and then we cannot set up any type of relationship by all the unique characters value. uh, that's only can be done when for the natural language processing, for when we are understanding the what the customer feedback is, like when what is the customer feedback is negative, positive, or neutral, that type of a thing. Okay, whatever it's, but now in pandas 3 also we have the string type. So I want to tell you that the main purpose of the pandas is to make visualization of the data easy for the human, because tabular form of data is extremely slow when comes to the processing for our system process tabular data slower than the like the JSON format data. JSONs are extremely faster than the tabular form. But pandas had work a lot to make this itself fast. It's up to, it can gain up to the speed of the C and C++. So if your data is in the pandas, it runs with the speed of the functions run with the speed of C or C++, which is normally 2 to 1000 times faster than the normal Python code. Okay, just give me a second. Let me just reconnect if I am breaking. Just give me a second. If voice break again, please let me know. If voice break again, please let me know. Okay. Now let's start with importing the pandas. Practical analysis will help us. We can say import pandas pandas as pt. Okay. Now we can build the pandas also from the this Python dictionary, or from the list, or from the uh, numpy array. Okay, let's start from building a pandas data frame. Let's start building the pandas data frame from a dictionary. Okay, let's build the sample dictionary. That's only for a demo to understand how dictionary can be converted into a panda data frame. So let's say data equals to curly braces for a dictionary. The key, for an example, let's take key as a, and let's assign some value like 2.1, 2.01, something like some version. Then we can say b, like it's like the it's like something like an array. Let's say np dot array orange. Let's take the orange, and let's take the value from 123 to um, I wanted the distance of 111, 23 to, let's say, 30, 7 different values. Okay. Next, let's take, so this is a numpy array. Let's take the c, where we can have the categorical data of the pandas. We can say pd dot, do not forget, okay, do not forget to import it and just re-execute it. Green tick means all has been executed. Just write the import pandas as pd, and just re-execute this shell, please. Just when you are getting the right tick, done, that's done. Okay, so pd dot categorical for the categorical values, like this is worker, or I can say, okay, let's say this is worker, and then we have the manager. Okay, other we can have another worker. So we want 7 different values. So worker. I can repeat worker and manager again. So we have 4 and 1 5 values. Two more, let's say engineer, engineer. Okay, and again, let's say last two are engineer. Shape of each must be same. Okay, that's what we want initially here. Next, uh, let's take these, create a string column, d, something like, and can have the something like uh, that's the mm, machine, something like machine, uh, table, table, desk, desk. Okay, 4 5 field, field. Okay, next. Okay, it will be field. It's type. Okay, whatever. It's fine. Now you can see here. Okay, let's one more thing. Let's take E also here, and E I can say none. So to make a Panda data frame, that means the Panda, something like the tabular data, either your value of the dictionary must be of same length, or it must contain only single value. If it contains only single value, then that value will be repeated along the each value. Okay, and if it contains the equal number of value, then it will be assigned according to that only. Okay, other thing is that if it contains 2 3 or different number of values, that will not work, it will throw an error. So either all the values must be of same length, or it must be of only single value, like list of same length, like list of 10 values, array of 10 values, whatever, like that. And I have the one single value, it will not work. One value is one list of 10 values and another list of 2 values. No, in that case it will never work. So here we have the dictionary. This is our data. So you can see it's a single value, then it's arrays of 1 2 3 4 5 6 7 values. Similarly, we have the list C 1 2 3 4 5 6 7 values. Then we have the okay, it's a Panda Cs, which is a categorical form. Then we have the this list is of 7 values, and e column is of one single value. That's fine. Let me just share you this thing. Now we can create a Panda data frame. To create a Panda data frame, for the data frame, basically df abbreviation is used, which is short form of the data frame. To create a data frame, you can say pd dot data frame, like this. Okay, after passing the data frame, we can pass here the data. We can say data equals to data. Now to see a data frame, we can say df. So here you can see data frame. Created from our dictionary. So this is how you can create a data frame from the dictionary. Another, we can also create a data frame from the numpy array, from randomly generated numpy array, or from the predefined some numpy array. We can use any of those. But before coming to that, let us see some more method from the this data frame. So you can see here the index column name is same as what we have in the key of the dictionary. Now these are the index value that is automatically assigned as 0 1 2 3 4 5 6, whatever the number of uh, rows are there depending upon the number of values in our list, equal count lists. uh, Another thing, where we have only a one single value, like in the case of the a, that value is repeated along each and every row. Similarly for e also, none is written repeated along each and every row. Now if you want to give the custom indexes, like here we have the 0 1 2 3, you can say here dot index equals to, that should be again as a list of same length, how many total row number of rows you will be having in this data frame. So as we will be having the seven rows, so we need a list of seven characters or whatever the strings. Also in Python we don't have characters type, we only have these strings. Okay, so let me say list of sorry, list of let's make the list of the seven different characters. So we can say a b c d e f g, seven different characters. So now you can see here the row indexes will be a b c d so on, so a b c d e f g, like that. Now if you want to see the shape of the data frame, you can say data frame df dot shape, that will give you the number of rows and the columns. Then you can also have the df dot size, that will be the total number of values, which means row multiplied by columns. Okay, then you can also see the column names, like df dot columns, this will return you the column names. You can also see the index names, you can say df dot index, so these are the index names, like this. Then the important one, we have df dot info, this will tell you the info about each and every column and the each or every row, summarize info like this, where you can see here it's the panda data frame object, it's printing. Then its index range is, it has the seven values starting from a to g. Then total five columns are there, these are the column indexes. So each column and row also have their integer indexes. It's like if we are like you have the student and student have their roll number also. So similarly, we have the index name and index integer value also. The index is at which uh, particular index is as which how they are ordered. So at as A is the very first index, B is the second index, and so on. Then it's so this is the column index, this is the column name. Then how many total non-null values are there? Non-null is the very important thing in the case of pandas and numpy. Pandas and numpy doesn't consider all the values as null. Pandas only consider the value as null, either it is a numerical null, so either it is the np dot none, which is not a number, or it is np dot Okay, we have np none, Pythonic none. Yeah, np dot null also there. So either it is a numerical none or it is a Pythonic none. Only those value pandas consider the none. So either you can search for pd dot is na. So that is the function to check whether the value is null or not. So there they have clearly documented this thing. Let me show you. So here you can see clearly they have documented this thing. So this function takes a scalar array and consider which it consider none, which is the nan, not a number value according to the numpy or the pandas. Okay, Pythonic none. It's a Pythonic none. What we have, or it's a none in the object type, or it's a date time none. So we also have the date time value. So if it is a date time none, or it is a numerical none, or it is the object type none, means string type none. That's the thing. So it will be not considering hyphen asterisk as the null value. That is, you have to manually search for those. So I have shared this link in the group. You can go through it. So just let me come back to where are we. So here. Okay. Now this is the info. Here you can see as it contains the Pythonic none. So here it is saying zero none values because all the values are null in this case. Next important thing we have df dot describe. So basically describe works on numerical values by default. Okay, it's generate the, you can see here it's return the statical descriptions of the data frame. So only as we can see from the info, the data type. So this column and this column is only the numerical type. So it will be by default given the statical different description only for the column A and the column B. It will be not giving the description for the categorical and the object type column. For that, I will be just telling you in a while how we can get that thing. Okay, so this is the data type, and data type only the integer data type description, statical description will be written by default. Then we have the total number of column counts of each type. So categorical type we have the one column, float type we have the one column, int type we have the one column, and the object type we have the total two column counts, that is D and E. So here it is showing the total number of the column counts. Let's see how we can go for the statical different description for the object type. To get the statical description for the object type, you have to just say include same way the object is written here or same way categorical is written here. If you want it for the categorical type, you can say category and pass it as the string. This is for the statical description for the categorical type. So it will be like this. In the case of the numerical values, we have the total number of non-null values count. Then we have the mean of those column. Then we have the standard deviation of those column. Then we have the minimum value, maximum value, and here we have the first quartile, second quartile, and third quartile. Second quartile means median, and first quartile means median or of the lower values than the median, and 75% means median of the values which are more than the median, upper half median, or we can say. So for this, we have the very good description on the Wikipedia page of the interquartile range. Those who are not familiar with that, let me share that link so you can go through. They have clearly defined how we can calculate the Q1, Q2, and Q3, and they have also made the box and whiskers plot. Very, very important plots. As categorical is non-numerical type, so we can not have the mean median type of the thing. Here we have the total counts, total unique values, mode. That is what we find out for the categorical values. So here we have the mode, then the frequency of the mode, so most occurring value, and how many times the most occurring values occur in our data frame. Similarly, we can also do for the object type. We can say here object object type, descriptive statistic of the categorical type, and descriptive statistic of the object type. So as in the E column, all values are null, so that's why count is 0, unique value is 0, most occurring value is none, and frequency is none. While in the D, we have the total count for the total number of values, uh, overall unique values, most occurring values, and the number of times the particular most occurring values occur, the frequency of the mode. So this is how you can get the info of the data, the statistical analysis of the data, and as I was showing you the things, you can get that it's good for the visualization. We can easily visualize the data by using the pandas. That was initially not possible in the case of the numpy array. So they are specially built for the visualization purposes, to increase the visualization purposes. We can also have the time data, and in pandas we also have the 1D data. Previously in the pandas we also have the panels and the 3D panels, so for the 3D data and the 4D data, but visualizing for 3D data and 4D data in a tabular form is a difficult task. So now that has been dropped out. I think from 2020 we don't have that thing. I don't remember the current year, but nearly 2019 or the 2020, Panda has dropped that thing. Now we don't have the 3D panel or the 3D panel. We in that place we have the multi-indexing. So by using the multi-indexing, we can just represent the n-dimensional data in the 2D form. It's like that. If you have the 3D data, you can take each depth axis as a slice, and you can use that slice index as the row index. It's like that. Okay, first row of first slice, first row of second slice, first row of third slice, so on, like that. So you can, if you want, you can go through the multi indexing. in the pandas. Let me just share you the documentation. Oops, it's not copy pasted. One thing more, I can just copy paste that thing. Advanced indexes. This is an documentation. Okay, so if you want, you can read this official documentation. Next, we also have the 1D data in the Python, that in the pandas. 1D data is called the pandas series. Like if we have the 1D array, we can make that the 1D array as the series. I can say here np s for the series pd dot series. Let's generate it from the numpy np dot range. I need to generate the 26 values, and let's take it will be difficult, so let's take generate the 10 values, and I can give the name indexes as a list of 10 different characters: a b b c d e f g h I j k. So 3393. Okay, 3363911. One more. Let me just remove it. So this is the series 1D data in the pandas. Now, uh, for an example, it's a small, that's okay. But if we have a very lengthy series like of thousand or 10,000s of values, so to visualize, so that's not the proper way to visualize it. What we can do, we can say dot had. This will by default return first 5 values. You can pass here the any number, it can return up to that number of values. Like if I want to see the last values, I can say s dot tail, and let's say 3. So by default it will, by default, last 5 values. So here it is showing the last 3 values. So had starting values, tail last few values. Now, how we can access a value? So to access a value, we have the loc and iloc. Loc means locate. Iloc, integer locate. As I already told you, this indexes also have their integer values, like a is at 0, b is at 1, 2, 3, and so on. So either we can use the index name or we can use the integer values. So I can say s dot loc get me the value at d. So this will be get the value at index name. Okay, index name d. Similarly, we can also do the slicing. If I want from D to E, F, G, so D to G. So you can see here D to G. Important point is there, important and the limit is included, it's not excluded. That is the extremely important point. In loc, it's not like the we have done the slicing, upper limit is included, end point is included. Very, very important point here. Another way, you can also do like I dot loc list of indexes like D, A, C. And remember, order matters. The or in the order which you pass here, in the same order it will be returning. List of index names. So same order. So first will be D will be coming, then A will be coming, then C will be coming. Order extremely importantly matters here. Now same way we can also get it by using the iloc. We can say s dot iloc is for integer locate. Now to get the D, so what will be at D at what index? A as 0, starting counting A as 0, B as 1, C as 3, and D as 4. So we have to say here 4. That is integer locate. Locate by X index. Index of the indexes. Okay. Here also we can use the allocate. So D is at 4 index, D, E, F, G. So 4, 5, 6, 7. But here upper limit is not included. So we have to go for 8. Important. Again, end point not included. So that is the difference between the loc and iloc. So remember it's coming till, okay, it's D is not as 4, it will be at 3 and this will be at 7. Okay, D to G. So D at 3, 4, 5, 6. G is at 6, but we have taken still 7 because upper limit is not included in this case. Then we can have S dot alog. We can also pass the lists of indexes. D is at 3, A is at 0, and C is at 2. List of indexes, index. So here in the same order. So this is how you can access the values by using the loc or iloc. Either you can access a single value using the indexing, or you can access the multiple values using the iloc. Remember, when we don't have the custom indexes, when you don't pass the custom indexes, means when we have the indexes same as the integer value, in that case loc and alloc might look you similar, but they are not similar. So in that case, if we have not given the here this index list, so in that case, okay, I can just copy paste this thing. Okay, and I can name this as S2. So in this case, you can see here we have 0, 1, 2, 3, but still integer values also have their index as integer value. So 0 index is at 0 in 0 index is 0 only. So remember, it might look you similar, but they are not similar. In this case, loc will be also working as, because they are the integer value only. So in that case, we can use the loc as 3 comma 7, 3 comma 6. Upper limit is included. That is in the case of the loc. Okay, upper limit is included, but when we are trying to access using the iloc, because now it will be looking for the index of the index. So index name is one, but that name also have the index which is, remember, now in this case upper limit will be not included. So these are the very important thing you have to keep this in mind. Here the index in name is an integer value, so its index will be also that zero name is index, zero index is the name, and that index also have its own index. So this is by the integer value of the row. It's like the integer value of the row. It is why the name of the row. So the name of the row is also zero, and its index is also 0. And there is also, I can confirm this by the also the doing the time analysis on this time it. So integer locate is slower than the locate. As dot locate, if I want to locate some value like 2, same way, if I try to locate the same value by the iloc, iloc, and this will be, this will be slower than the loc here. Okay. Okay, in this case, it's getting more fast than this microsecond, but usually it was slow. Okay, whatever. It's yeah. It's in this case, it's getting faster. Whatever they might have updated the thing. It's fine. Now let us try to make a data frame. Data frame from randomly generated array. So let's make a big df. So df equals to pd dot data frame, and in that case I will be using for the data is equals to np dot random dot uniform. This is used to generate the data from the uniform probability distribution. Yeah, sorry, that's you are correct, that will be s2. This will be also s2. Yeah, here also it will be s2. This is because I have just updated that thing. Okay. Thank you for the updation. You are correct. This must be S2. Okay. Now, random uniform. Then I can give the shape like it will be generating the uniform probability distribution with the low value. Okay, let's take the low value as 0. Between 0 and 1, I want to generate using the uniform distribution for probability distribution. uh, Let us say shape as the 5 column 10,000 values. Okay, and we can also pass the column name. Okay, let's just show you the first show you the built data frame. We can say df dot hat. If you don't say df dot hat, then it will be the size. So rows column. So 5 rows, 5 columns, and 10,000 rows. So dot 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 means represent. It contains multiple value that had been hidden due to the length, the large length of the data frame. So we can use here the head and the tail to see the first 5 values, or let's see the first 3 values. We can also give the custom data frame names. This custom column names. So I can say columns equals to. So there are 5 different columns. So I can say list of A, B, C, D, E. So the column names will be A, B, C, D, E. Now in this case, how we can access any value? So when you have the data frame, similarly, you have to use loc and iloc. To access, you have to say df dot loc, first the column name, then the row. First the row, then the column. So like if I want to access third row D column. So this will return me the third row D column value. So it's 0. Third row D column value, D column third. Okay, third will be the next one. You can see here 2 row D column. So this is the value. Third row D column value. Now if we want multiple rows, so we can say df dot loc third rows D column. Okay. Then if you want multiple rows, like I want from 5th to 10th row and the E column, row 5th. So 5th means that will be 4 here. Upper limit will be also included. So let's say 5th to 9. 5th to 10th row E column. So this is the E column. And if you want to access the multiple columns, so you can also say like similarly, first 0 to 9, that means first 10 rows, and from column A to column D. First 10 rows, column A to D. All values from column A to D. So first 10 rows, all columns from A to D. Similarly, we can also pass the list of rows or the column. Like I want the custom rows. I want the 4th row, 5th row, 6th row. And remember, order matters. So A to from A, I want till C. Okay. Row 4th. So 4th means 5th row, 6th row, and 7th row. Okay. So here you can see 4th, 5th, 6th row. That is the
Okay.
name. Next, we can similarly also use the uh, iLoc. Okay, same way. In that case, you have to use the column index also. Row index will be same because row 0 means 0 index row. Row name 1 means 1 index row. So the row index will be same, but the column index A is at the A is at the 0 index. So 0 to B at 1, C at 2, and upper limit is not included. So in that case, we have to say till 3. So this will be same as this one, same as this one. Okay. And if you want all the values of the column, one way is that for an example, if you want the all the values of column A, so you can say df dot log all rows of column A, column A. Another way, you can also get this by the ilog df dot log, sorry, alog all the rows of column A is at 0 again. Then we can also directly access. If you want to access the column directly, you can access without the log or ilog. Okay, you can also fetch it directly. Another thing, if you want to access a single value, for accessing the single value, the fastest way is not alloc, not alloc, it is act. Act is specially designed to fetch a value fastly. So I am using time it for the time profiling. Let's try to fetch a value df dot log single value. Okay, only this is all the demo only for the single value, like something like 1200 row and column D. Okay, let's try to do same thing using the alloc. Alloc that will be at 0, 1, 2, 3. D will be at 3. Whatever, we have just evaluating the speed. So in this case, you can see alloc is slower. It will be the slowest. And this will be the log is slower than at for. So this is dot at for single value. Okay, so we have percentile time it df dot at. So 1200 and at D, fastest of all. Try out this thing. Now, if you have any query, you can ask. Otherwise, we can wind up this today's session here only. So, any doubt or query from anyone? Lok and alok, the difference between the, okay, just give me a second. So at is the special method for accessing a single value. If you are accessing a single value, not like multiple values, like particular row, particular columns value, a single value, single shell type of a, like we have the Excel, we want this Excel single cell value. In that case, at is the fastest way of doing. So fastest way of accessing the value is the at. So same thing can be done by lok also or ilok also, but lok and ilok are slower than at. So at is the special method of accessing the value, accessing a single value. By using the lok and ilok, we can access the either a single value or a part, or the or a single column, or a single row, or the multiple columns, the combination of the multiple row and the multiple column. That is the thing. Similarly, at we also have the I at, but I have not shown here because sometimes it is slower than lok and ilok also. I at for integer at, that is like that, integer at. So that is slow, so that's why I have not shown that thing. The difference between the lok and ilok is that by using the lok, we access by the name of the row and column. Like here, we are using the lok, we are giving the column names, name of the column. What we have substituted here, columns equals to list of like that, and here you can see the column names at the very top of the data frame. So by using the lok, we can pass the column names, and row names are same as the row indexes, or we can also pass the row names, like the, in the case of this, when we have made a very first data frame, here you can see, here we have the column names and the row names. Now, like what is the index of a row? Index of a row is 1, oh sorry, 0. So a row is 0, 1, and so on. So if you want to access by using the index of the row or column, integer value of the row or column, so here I will be using the df dot ilok. Now here a b c d will not work. We want the index, or actual index of the column. So like b is at 1 index, c it has 2 index, a is at 0, 1, 2. So if I want this 23 worker, 24 manager, so that means I have to say I want the row index is, it's a name of the row. Okay, this is the name of the row. We want its index, so its index is 0, 0 to, this is 1, b is at 1. So 0 to 2, because upper limit is not included in the case of ilok, it is included in the case of lok, but remember. Then b is at the 1 index, so we can say the column 1, 2, c is at column 2, so we can say till column 3. So this is the way how we can access by using the I look same 23 worker 24 manager, 23 worker 24 manager. Now same thing we have to do. If by using the log, we can say df dot log directly the name, like a to b. Here we can say a colon b, first the row, then the index. Now here we don't have to worry about the upper limit, because upper limit is included in the case of the log, when we are accessing by the location name. So this is by the name of the row or the column, and ilog is by the index of the row and the column. If we have not given the custom name or the column, in that case the index and name are totally similar. So that's why here we don't have to, we can use the integer values similarly, because the same row name and row index are same. Yes, still any doubt? Still any doubt or query from anyone? Thank you. Yes, happy to help here. If you have any doubt or query, you can ask. Okay, sure. I am winding up today's session here only. We will be continuing from tomorrow. Tomorrow we will be seeing the, not tomorrow. Remember, tomorrow there is no session because I will be traveling. Uh, uh, so for tomorrow there will be no session. Remember this thing, and there will be the session after day after tomorrow. So you will be having the session on Saturday and Sunday. So thank you very much.